Section 5.5, it's the way it's numbered in here. We're going to talk about systems of nonlinear equations, and then we're also going to talk about inequalities, systems of inequalities. But we're going to start out with nonlinear equations. So the key thing here is, you remember with linear equations, you only had a couple options. They either intersected once, they intersected all the time, or they didn't intersect at all. With nonlinear equations, since they're not lines, they can be curves or some other shapes. They might intersect more than just once. So it is possible to get more than one answer in these. It is still possible to get no answers. It's possible to get one answer. There's a bunch of different options here now. Okay? Because of the curves. Some are lines and some are curves. So let's take a look at this. I will just tell you that this one, or these two equations, represent, one of them is a circle, and one of them is a line. So if you think about a circle and a line, it's possible they never intersect, right? A circle and a line. It's possible that they intersect just one time. And then it's also possible that the line goes through the circle and they intersect twice. Does that make sense? So that's what we're going for, either 0 or 1 or 2 solutions. All right, so let's see what we can do to figure this out. Now, I've given us a little bit of direction here, and I've said, let's go ahead and solve this using substitution. You do not want to have to get one of the x squared or y squared things by itself. So you're going to deal with the line. And which one do we think would be the easiest to get by itself here? But what variable? Y. The y, right? So how are we going to get the y by itself?
Plus 3x.
We'd have to subtract 3, because the negative goes with the y, so we'd have to subtract 3x. That would give us a negative 1y equals negative 3x plus 4. Then what? Divide by negative 1. So y equals, this is going to be a positive 3x minus 4. Is that okay so far for the first one? First part? Now, once we get to that point, we're going to substitute. So we're going to replace the y with this. So we have to go to the other equation. X squared, we're going to leave that alone. This was y squared and equals 16. What are we replacing the y with? 3x minus 4. Okay, now I'm going to go over to the side and do this work, because 3x minus 4 squared means we have to multiply 3x minus 4 times 3x minus 4. Does that make sense? And we have to distribute. So we're going to multiply 3x times 3x, and what is that? 9x squared. And 3x times a negative 4?
Negative 12.
Negative 12x. And then a negative 4 times 3x, that's going to be negative 12x again. And negative 4 times negative 4? 16. Positive 16. So if we put that all together, let's come back over here. This is going to be x squared plus 9x squared minus 24x plus 16 equals 16. So this part right here is the part that came from over here. Okay, is everybody okay with that so far? Now, because we've got x squareds in here, this is a quadratic equation. It's been a long time, but we had 2 methods of solving quadratic equations. Both of those methods required us to move everything over to one side. So let's subtract this 16. So that's gone. And let's combine like terms. Here we've got these two we can combine. What would that give us when we add x squared plus 9x squared? It'd be 10x squared, right? Because we're adding. If you were multiplying, it'd be x to the 4th, but we're not multiplying, we're adding. So 10x squared minus 24x. And actually, those cancel also, right? Does that make sense? 16 minus 16? So I wouldn't use quadratic formula here because we don't even have 3 terms, right? The c value is 0, so let's just factor. What can we factor out of both of these? A 2 and an x. They both have a 2 and an x in them. Now remember, when we factor out, we're dividing. So what does this 10x squared become when we factor out a 2x? 5x. And then minus, and what does the 24x become when we factor out a 2x?
12.
12. Okay? So now what do we do with the two factors? Yeah, so we've got 2x equals 0. We've got 5x minus 12 equals 0. This one's easy, just 0. This one takes a couple of steps. What do we have to do there?
Add 12.
Add 12. So 5x equals 12. And then what?
Divided by 5.
Divide by 5. Now, dividing by 5 actually comes out pretty nicely. It ends up being 2.4 and stops. So there's no like messy bunch of fraction stuff or decimals. So we can just make that a 2.4. So we know in this case now there's going to be 2 answers. Once when x is 0 and once when x is 2.4. Does that make sense? So then we go back. Remember we solved for one variable. We have to go back and substitute in to find the other variable. The difference is we have to do it twice. Once when x is 0 and once when x is 2.4. So where's our equation? Right here. Right? You're going to plug it back into here. So for the first one, when x equals 0, we're going to get y equals 3 times 0 minus 4. What will that be?
-4.
-4. And I'm going to put this up here. So 0, -4 is one of our solutions. That's one point where it's going to cross. The other time is when x equals 2.4. That'll be y equals 3 times 2.4 minus 4. If somebody has a calculator, they can figure that one out for us. I think it's going to be like 3.2 or something like that.
Yeah.
3.2. So the other answer is when x is 2.4, y is 3.2. And those would be our 2 answers. So this was that case where the line cut through the circle and intersected it in 2 spots. Okay? So that is, you see how it's really the same steps? We just are going to end up getting 2 answers because we'll have some quadratics that happen. So we do have to kind of remember that from the past. You may have to review a little bit of your quadratic stuff, but you either factor or quadratic formula. Those are still the 2 ways that you solve those quadratics. Okay? Questions on that one? We're going to do some more, but any questions on that first one? All right. So, and these answers right here, this is 12 divided by 5, which is what we had. I just left it as a fraction. And this is 3.2 that's just written as a fraction. So you can write it as a fraction or a decimal. Either way is fine. All right. Okay, this one. Again, I'm giving us a little bit of a suggestion to maybe solve using elimination. And if we're going to solve using elimination, the easiest one to cancel, or the one that eventually will be the easiest to work with if we're going to cancel, is if we can cancel out the x squareds. Because then we're not going to have to worry about quadratics, right? Okay, so we want to think about this. This is a 3x squared, and down here 5x squared. What can we multiply and make both of those into? What's the smallest multiple of those two? 15, right? And if I want to make it into 15, what am I going to multiply the top by? 5. And what am I going to multiply the bottom by to make it into 15? 3. Now remember, we do need one of them to be negative, right? So far, they'd both be positive, correct? So you guys get to pick which one do you want to be negative? The bottom one? Okay. It doesn't matter. Just one of them has to be negative. Okay, so minus. Multiplying the top. Remember, we multiply everything by 5. So 5 times 3 is 15, x squared. 5 times 2y is going to be 10y. 5 times 26, 130. On the bottom, negative 3 times 5 is going to be negative 15x squared. Negative 3 times 7 is going to be negative 21y. And negative 3 times 3 is going to be negative 9. Okay, so make sure one of the most common mistakes I see students make is they don't multiply by everything. They have to multiply the 5 by everything and the negative 3 by everything. They usually get the first two, but for some reason it's the constant that usually gets left alone. But multiply everything by the 5 and the negative 3. So with elimination, remember what we do now? We add. What happens when we add the 15 and the negative 15x squared? Right? That's the point. They cancel out. How about 10y plus a negative 21y? Negative 11y. And then 130 minus 9, 121. What do we do to figure out what y equals? Divide by negative 11. Negative 11. We get y equals negative 11. Okay, so we've solved for one of them. Notice how many answers we're going to have this time? Just one, right? So what are we going to do with this? Well, we plug it into either one of these. Actually, we're going to get more than one answer, I just realized. We're going to plug it into either one of these. Which one do you want to plug it into? Okay, top one. So let's plug it into the top one. We're going to have 3 times x squared plus 2 times y equals 26. And what do we just figure out that y equals? Negative 11. I should say we're going to have one y value, but we're going to end up with 2 different x values. So 3x squared, this would be minus 22 equals 26. We're trying to get that x by itself. What are we going to do next? Add 22. So cancel that. 3x squared equals 48. Then what? Divide by 3. X squared equals 16. And our last step here, take the square root of both sides. Now, what do we have to remember when we take the square root of both sides? We're going to get x equals plus or minus, and the square root of 16 is 4. So here's what that means. No matter what, y is negative 11, right? But x is either a 4 with that negative 11, or x is a negative 4 with the negative 11. So we're actually going to get 2 different answers. I should have told you right at the beginning, these are both these are both parabolas. So, and I think they both open down. But so the idea is you maybe have one parabola that's like this and another parabola that may be like this, and they're intersecting twice. Okay, but again, you could have one intersection, you could have none, you could have 2. I don't think we could have 3 with parabolas. I think the maximum would be 2. But you're going to get any number of possible solutions here. Okay? So does that make sense that we have 2 answers? Negative 11 was the y value for both, but when we plugged it back in and substitute back in, we get not only a 4, but also a negative 4 from taking the square root of both. Okay? Questions on that one? All right. So get those 2 answers. Now, again, as I mentioned, on the test, I'm not going to tell you which method to use. You can use whichever method you want, and I don't have any problem with that. Again, though, some of these are going to be easier using one method over another method. So what do you think about this one? Which method would you maybe try to use this time? I think substitution, because on the top one you've got squareds, and the bottom one you don't have any squareds, right? So to try and do elimination would be a little tough. We could do it, but it would take kind of a lot of manipulation and work. So if we're going to substitute, what variable do you think would be the easiest one to get by itself? Sorry?
What, the bottom one?
The bottom one, and which variable? The y. And how do we do that?
Plus 2x.
Add 2x. So we get y equals 2x, and we're already done with that part, right? We have isolated the y. We have solved for y. What are we going to do with that? Well, in the other equation, we are going to replace the y with what?
2x.
2x. Now, one thing I want to mention again, this is a circle, this is a line. We already drew the picture for that, right? It could intersect 0 times, or 1 time, or 2 times. So that's kind of our options. So let's figure out what happens here. What do we get when we square 2x? Remember, that means 2x times 2x? So what is that going to equal?
4x.
4x squared, because 2 times 2 is 4, and x times x is x squared. Then, add these together. 1x squared plus 4x squared is 5x squared. This one is not going to come up nicely. What will we do after that? Divide by 5. So x squared equals 4 over 5. Then what? Square root of both sides. Now again, when we do that, we have to put in plus or minus. Now this one, again, doesn't come out nicely, right? So here's what we have. When we do this, we can do square root of 4 on the top and square root of 5 on the bottom. Square root of 4 is pretty easy. What's that? 2 on the top. But the square root of 5 on the bottom, we can't really do a whole lot with. Now again, do you remember way back when we were talking about these radicals? Do you remember how we simplify this? Because we don't want to have the radical in the denominator on the bottom. Remember how we deal with that? Here's how we deal with it. We multiply by that square root of 5 on the bottom. But if we multiply the bottom by that, we have to also multiply the top by that. And I want to make sure you understand why. Because this is a fraction, right? What is this fraction equal to? Square root of 5 divided by square root of 5? 1, right? And what happens when you multiply something by 1? Doesn't change the value, right? So we're multiplying by 1, doesn't change the value, it's just going to change what it looks like. So this would look like plus or minus 2 square root of 5 over, the bottom just becomes a 5, because square root of 5 times square root of 5 is square root of 25, and the square root of 25 is 5. Okay, that means we're going to have 2 answers at least. One is going to be 2 square root of 5 over 5. And the other one's going to be negative 2 square root of 5 over 5. How do we figure out the y values? We go back to where we started, right? Because we know that y is equal to 2 times the x value. So y is going to equal 2 times, if we do the positive, 2 square root of 5 over 5, what will that be? And maybe this will help. Remember, 2 as a fraction is 2 over 1. So do we see it's really just 2 times 2? The square root of 5 has to just sit there. So 2 times 2 is 4. Square root of 5 on the top, and then a 5 in the denominator. Then what happens if we put a negative here? For the other one?
-4.
Just negative 4 square root of 5 over 5. So those are our 2 answers. Okay, so if you're going to use substitution, you're always going to go back to that variable that you isolated, in this case right here, and you're going to plug that back in. Okay, so we get those 2 answers. 2 square root of 5 over 5, comma 4 square root of 5 over 5, and then same thing with the negatives here. Okay, does that make sense? So nonlinear systems, that's how they work. Okay, here's one more. I think this is the last nonlinear system. The difference is this one is a circle. The top one is a circle. The bottom one is what we call a hyperbola, which is another shape. Now, a hyperbola is like two kind of like sideways or vertical U's. So the options we have here is you might have a circle, and it's possible that it doesn't intersect at all. It's possible that it intersects 4 times. It's possible that it intersects twice. It's even possible that it intersects once. But I think those are the options: 0, 1, 2, 3, or 4. Okay, and then our job is to figure out which one it is. So what option would you maybe choose this time? I think elimination. You got squareds for both of them, right? Elimination would probably work pretty easily rather than trying to substitute and get an x or a y by itself. If you're going to eliminate, what would you multiply by? Or what could you make everything into? Say that a little louder.
With the x variable?
Okay, and what would you have to multiply? If you're going to do x, what would you have to multiply this by? A 4? Except we would need it to be a negative 4. Does that make sense? So remember, we're going to multiply everything by the negative 4. I'm just going to put it down here. Negative 4x squared, because we're not going to do anything with the bottom, right? Negative 4x squared minus 4y squared equals negative 16. And then we add these. What happens to the x's, the x squareds?
Cancel.
They cancel. Here we get negative 13y squared. Here we get 20. What are we going to do to figure out what y equals?
Divided by,
Yeah, you're right.
divided by negative 13?
Divide by negative 13, because it's multiplied, right? So divide by negative 13. I'm going to leave that as a fraction for now. But the negative really doesn't matter where it is, right? The whole thing ends up being negative. Positive divided by negative is a negative. Then what do?
Square root.
Take the square root of both sides. Y equals plus or minus the square root of negative 20 over 13. I guess the negative migrated up to the top. What does this tell us? Do you remember what this means right here, this negative inside of the square root sign?
The I.
It means the I. It's imaginary. What that tells us is they never intersect. There's no real numbers that will give us a solution here. So we would just say, in this case, no solution. Okay, that makes sense? If we would have tried to eliminate the y's, it would have been kind of a similar case. But it would, I think we would have gotten answers for the x's, but then when we tried to use the y's, we would have still gotten imaginary, if I remember correctly. I don't know. But in this particular case, no solution because we have that imaginary. So it'd be something like this where they don't ever intersect. Okay. All right. Now, we've kind of been pointing it out as we've gone along, but I just want to mention that if you have a graphing calculator, which we're not going to be doing any problems with a graphing calculator, but if you had one or some ability to graph, and you don't have to write this down, but just so that you kind of have seen it, what we would do if we want to try to solve these graphically, and you could do this with linear, we could have done this in the last lesson, but we graph each equation, and we do that by expressing each equation in a way that we can put it in the graphing calculator or on the graphing computer program or whatever. Usually that means we have to get the y by itself. And we graph all the equations on the same screen. And what do you think we're looking for to find the solutions? Remember when I've drawn the pictures, what were we always looking for?
The answer.
But what does the answer look like on the picture?
The
points where they intersect, right? So it was where the two lines intersect, or it was where the curves intersected, okay? So once we graph it, we find the intersection points, and the solutions are those x and y coordinates, okay? So if we are graphing it, that's how we would do it. Again, we're not going to be doing that. I think I maybe have like one problem like that on one of your homeworks where you're graphing two lines. and you graph it on the computer and show the intersection point. I can't remember if I took that out or not, because I know it was in there. But we also want to look at tonight inequalities. And when we do inequalities, we have to graph them. Okay? So when we graph inequalities, this we are going to do. The first thing we do is we graph each inequality. Now, I don't know if you remember, but let's see. I have to think if we did inequalities in this class. Yeah, we did. So remember when we did inequalities, we'd have a boundary point, and it was either a filled in or an open circle. And then it either went to the right or it went to the left from that point. Well, the difference is now we're dealing with two variables, x and y. So our boundary is going to be some sort of a shape, either a line or a curve or whatever. And the difference is you can't have like an open circle line or a filled in circle line. So what we do for the boundaries, instead of open circle, closed circle, we use a solid line or a solid curve or a dashed curve. So solid means that that endpoint is or equal to, or that the boundaries are equal to. The dashed one would mean like the same as an open circle. So we're going to do some examples like that. Then we identify the solutions, and the solutions are all the points that are part of the solution of each inequality. And again, I'm going to show you how to do that so that we see how that works. Okay, so let's do this one, solve the system. And you'll notice I've got a graph here because in order to do these, we really have to graph them. So notice the first one, the boundary is a line. The second one, the boundary is a line because there's no squared stuff or anything like that. This one is already in what we would consider slope-intercept form. So let's see, I'm going to draw that one in blue. So when we graph a line like this, where do we start? The top one. The 4, right? And it's on the y-axis, so we start at 4. 1, 2, 3, 4. Okay? Then what do we have to look at? The slope. The slope is -2. Now we want to think about that as a fraction, so it's like -2/1. That means we go down 2 to the right 1. Down 2 to the right 1. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and so on. We just keep going. Once we've got that, we also could go up 2 and to the left 1. Okay, so that's where the boundary is going to be. Now, here's where we look at this. Is that boundary going to be a solid line or a dashed line? Solid, because it's an or equal to. So this is a solid line. Okay. And then the other thing we look at is y is less than. Y's go up and down, correct? When we were dealing with x's, we were dealing with left and right, but y's go up and down. Where are the big y values? Are they up or are they down? They're up. So that means the small y values are down. We need y to be less than this boundary, which means we need to go down. All the values that are smaller are below this line. So from this line, we go down. And I mean, that keeps going this way because the line keeps going up forever, right? That makes sense? So from your line, you just draw lines down. That's the area that we're looking at because it's less than. Okay? Now let's graph the other one. I'll do the other one in green. Now this one's a little bit different. X is greater than -3. Do you remember what happens when there's just an X in our line? It's one of the special lines. It's either going to be vertical or horizontal. X equals lines, or X lines are vertical lines. This means X is always -3. So if we look at -3 for X, that's here. Or it could be here, or here, or here. Remember all the points where X is -3? So that's where the boundary is going to go. Is this boundary going to be solid or dashed? It is dashed because there's no or equal to sign here, right? See how this one had the or equal to sign, so it's a solid? This one does not, so it's dashed. So our boundary line goes right here. Now, we're kind of back on the, because it's x's, right? X's go left and right. So if we need x to be greater than, which direction are we going to go? Right or left?
Right.
To the right. That's where the bigger numbers are, right? So this one actually goes this way from the line. Now remember, our solution is all the points that work in both inequalities, right? Has to work in both. So that means it has to be below the blue line and to the right of the green line. Do we see where that is? It's this area right here. Below the blue line and to the right of the green line. Do you see how that's where the blue and the green overlap? Okay, whoops, my mask is falling off. I'm really not taking it off this time, like last time I evidently did. Okay, so here's a little bit nicer picture. And we can see the boundary at -3 is dashed. We got the solid boundary going down for the line there. And it's that area to the right of the dashed line and below the diagonal line, the solid line. Okay, and that's how you do inequalities. You just graph both parts. If there was 4, you can graph all 4. We're not going to do 4, but however many there are, you just graph them and find what works for all of them. Okay, any questions on that before we go try another one? All right. Okay, this time, the top one is still a line. And in fact, it's the same line, right? So I'm going to just redraw that. I should have left it there. Same line, start at 4, down 2/1, down 2/1, down 2/1. And we said it's what kind of line? Solid or dashed?
Solid.
Solid. And then it's everything below that, right? So from that line, we can draw down. Okay. So that one was actually the same as the last one. Now, this one, does anybody recognize what shape this one is?
V.
It's a V shape, absolute value. Remember, that was one of our, what do we call them, toolkit functions? Okay, so it's a V shape. And normally our V shape just looks like this at 0, 0. But what does this do to it? Do you remember your transformations? What does that do to the graph? Perfect. Moves it to the right 4 spaces. So this thing just moves over to the right. 1, 2, 3, 4. Now remember that our slopes, if nothing has changed, the slopes on either side are 1s. So we go up 1 and to the right 1, up 1 and to the right 1, like this. We also go up 1 to the left 1, up 1 and to the left 1, up 1 and to the left, up 1 to the left. And we get this. Okay. And is this going to be a solid boundary or a dashed boundary? Solid because the or equal to. So solid. Okay. Now the other thing we have to look at is it's y's again, right? So we're up and down. Y is less than. What does that mean? Not for y, that's x's.
Oh.
Y is less than means up or down?
Down.
Down, because it's less than. So we want below the green line. Okay. Now, remember, it has to work for both. So what area here do you see that's below the blue line and below the green line? Yeah, the left side, right? So this part, below the green, below the green, below the green, and then below the blue also. So it's all of that stuff. I don't want to color the whole board, but do you see where that solution is? Here, I'll put my picture up, and you can see that. Wait, what did I mess up here? Oh, the first one wasn't the same. I wasn't paying attention. Look at what that says. Greater than, right? So what does that mean? It means I need to pay attention and not just say, oh, it's the same as the other one. So the blue one, sorry about that. The blue one should have been above the blue line, right? Does that make sense since it's a greater than? That's what I get when I don't pay attention. And then the green one is below the green line. So now when we put those together, we get below the green and above the blue we get that area right there. Okay? I was like, that does not match our picture. Now it does, but it's because I wasn't paying attention. Even I make mistakes sometimes, right? So it's okay if you do too. It's fine. We all have to learn from our mistakes sometimes. Okay, questions on that one? Does that make sense? As long as I graph it correctly? All right. All right, let's take a look at another one here. Okay, so the first one is what shape again? It's a V shape. It has been moved which direction? To the left 3, but what else happened? It gets reflected. That's what the negative does. So let's draw this one in blue. So it got moved to the right, or sorry, to the left 3, 1, 2, 3. But instead of going up, it's now going down. Does that make sense? Now, is our boundary going to be solid or dashed?
Solid.
Solid because of the or equal to? Whoops, I missed those dots, but just pretend I hit them. Okay, now I'll be careful this time. Should we shade above or below this V shape? Because it says y is less than, and whoever just said it, it's below. That's correct. So below the V shape. Okay, that makes sense. Less than, below. For the other one, oh, who remembers what shape this is? It's a parabola. It's a U shape, right? It's a U shape. And then again, that was one of our toolkit functions. Again, normally the U shape is centered at 0, 0. Where has this one been moved because of this? Now be careful when you answer.
Down.
Yeah, it's not in with the X, right? It's outside. The X is squared, but this is outside of that. It's going to go down 8 spaces. So this moves down 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And then it just curves up like a U shape. So I'm going to give us a couple points. It doesn't have to be exact. I think it's actually going to be up here and up here. Is this going to be solid or dashed?
Dashed.
Dashed, because there's no or equal to. So it's going to look like this. Or so, I'm not sure if it hits there, but it's around there somewhere. Okay. And are we going to shade above the dashed line or below? Y is greater than, so it's going to be above. So above the green. What area works for both the blue and the green?
Where the parabola is.
What does that mean?
Right there.
It's got to be below the blue and above the green, right? So you see that it overlaps right here? Does that make sense? In the middle? Okay, and so, yeah, that's what we get for our shape. Okay, now, again on this, you might have one maybe that you have to try and graph it using the tools on the computer, but most of them, if I remember correctly, you're going to see that it's graphed already, and you're picking which graph is the correct one. So you're going to have to look at the above or below parts. You're going to have to look at the solid or dashed line boundary parts and pick the one that matches up correctly. Does that make sense? Just like we've been doing, but you don't actually have to do the graphing. I think, like I said, I think there's maybe one that you have to. All right, and I think this is our last one, if I remember correctly. So let's take a look at this. The top shape is what?
Parabola.
A parabola, U shape. And
how do you know that?
Sorry?
How do you know that by looking at
okay, we know it because of the squared.
it? Okay.
Anytime we see a squared, we know if the biggest power is a 2, it's a U shape, it's a parabola. Okay, now what has happened to this parabola?
Up 5.
Up 5 and reflected. So up 5, 1, 2, 3, 4, 5, and it's going to go down. Again, I'll just give us a few points here. Solid or dashed boundary? Dashed, right? So dashed boundary coming down here like this. That wasn't a very good one, but just pretend it's a nice U shape. Okay. And are we going to shade above or below that U shape? Below, because its y is less than. So that's going to be below the U shape. Right? Now, what's the other shape? What is this one? Boundary. It's a straight line, right? So let's go green for this one. Where do we start to graph it?
-2.
The -2 is the y-intercept. Always in the middle on the y-axis. And what does this slope tell us? That's 2/1. That tells us up 2 to the right 1, up 2 to the right 1. So starting here, up 2 to the right 1. And then we can continue this line going down this direction. Okay? Will that line be a solid or a dashed line? Dashed again, because there's no or equal to. Okay? And should we shade above the dashed line? Above. Oops, I gave that away. Okay, now what area works for both?
Right there.
Yeah, the one I gave away that I started coloring in right away. So that's the area that is above the green line and below the blue line. Right, or above the green line and below the blue curve. Okay, so again, like I said, I think on maybe one of them you have to graph it using the tools on the computer, the program, and on the other ones you're just picking. You just got to make sure that you check, okay, should my boundaries be solid or dashed? Maybe one of each, depending on the shape. Should it be above or below? And then pick the right graph. So, because you're going to have various options. Like I could shade down here and that would be wrong, or I could shade over here, I could shade over here, or I could have one of them solid and they should both be dashed or something like that. So it makes it into like multiple choice. You just pick the right one. So there's only 5 of these. I think there are a couple that are the maybe 2 or 3 that are the inequalities, and then either 2 or 3 that are the nonlinear systems. So make sure you're working on those. Again, if you guys run into trouble and you can't figure it out from the videos or whatever help stuff that you have there on the program, please feel free to email me and I'll do what I can to help you out. Okay.